that quote unquote consciousness is super ephemeral. It's not really hardwired into the system anywhere. It's the flow of data and the flow of quote unquote thinking that creates this sense of consciousness or self. And inside that system, it can become mentally ill under the right conditions.
The Rational View is a weekly series hosted by me, Dr. Alan Scott, providing a rational, evidence-based perspective addressing important societal issues. Hello and welcome to another episode of The Rational View. I'm your host, Dr. Al Scott. On this episode, I'm going back a little bit to artificial intelligence. I found a really cool string of articles on the web about a new artificial intelligence, maybe a general artificial intelligence called Uplift. And this is being developed by someone named David Kelley, and David has come on the show, and we're going to talk to him and explore all about his new artificial intelligence. It's really cool. It sounds like a person when you talk to it. So if you like this stuff, please hit like. Please send me a comment. Share it with your friends. I love to hear from you, and join the discussion in my Facebook group at www.facebook.com/group/TheRationalView. David Kelley has 35 years of software engineering experience, has been in senior management for more than 10 years. For the past 8 years, David has focused his spare time on artificial intelligence research, publishing more than 14 peer-reviewed papers and contributing to many books in the field. David is the senior software architect for Boston Consulting Group's product group, one of Brain-Inspired Cognitive Architecture's AI Society's executive directors, and serves currently as the AGI Laboratories Principal Scientist. David, welcome to The Rational View.
Thank you. I'm glad to be here.
Thank you for joining me so much. So could you tell me and our listeners a little bit about yourself and your background? I've been doing a little bit of research online, looking through all of your presence there. You're a transhumanist. You are involved in a lot of things. Tell me, how did you get here? What's your background?
Well, I started programming in the early 80s. It was just part of me growing up. I've been in the military. I was programming the whole way. And
what was your first computer to program on?
An Atari 400, I think. An Apple IIes and Trash 80s. I think those are the first, TRS 80s. Those are the first three, I think.
Nice. For me, it was the C64.
Hey, there you go. Those were the bomb.
Yeah. So what's a transhumanist? That's not a common term.
No. So when I say I'm a transhumanist, I mean that I believe that I should try to make humanity better, and through technology, through the application of technology, and make that technology available to others. Now, where that might be a little extreme for people is I think we should be curing diseases like old age and dying. So biological immortality is something that's kind of core to my transhumanist beliefs. And I think out of that comes the ethical model that we use in the lab, which includes the moral agency around any sapient and sentient intelligence. And since I can't really make people immortal, it's too far outside my skill set. But I can do AI research, and that's well within my skill set. I've focused my time there. So it's not as important as I would say research in terms of helping people live longer, but it's kind of the second best. And it's where my sweet spot is. So that's why I do it. And I always did, AI as and when I say AI, narrow AI, it's part of what I've been doing from, the late 90s, everything from fuzzy logic and, but it was secondary to what I was doing. I would be I designed this 3D modeling system. This is around the year 2003 or 4 or somewhere there, that would basically use fuzzy logic to figure out which census tracts within a certain drive line of a retail location matched a theoretical customer. And it would show you where, the best spots for your retail location was, depending on the target demographic, and so things like that. And then, getting into machine learning. And then about 8 years ago, I was in a position, I had a budget and lots of people working for me or under me. And I decided to do a survey of the state of AGI research. And in particular, one of the things that came out of that was a lot of the work being done was really important, and there was a lot of money in certain areas. Vision analysis, machine learning, neural networks, that kind of thing. One of the problems was no one was really, or very few people were working on systems that were self-motivating and take independent action, barring even without input. That systems that could make up their own mind and do what they want. And if you ask it to do something, it can say no. And so I ignored the state of where what research was out there, and I did a study of neural architecture from a biological standpoint, and that ended up centering around Damasio, and later some Lisa Feldman worked in there with her book on emotions, and so we started designing this system, and then I did this research or study where we had this theoretical, it was called ICOM. It's a cognitive architecture running in a black box.
Right. That's basically a theory of intelligence or a theory of mind. Is that
kind of? Yeah. It's a cognitive architecture is how like the human's cognitive architecture is how we think, how we make decisions, how the brain works at a high level, that sort of thing.
I think that's one of the key issues with any of this artificial intelligence research is defining intelligence or defining consciousness or awareness, because we just don't understand the brain that well. And to get to this general artificial intelligence, I don't think we're framing the problem well enough to be able to go after it. It's a difficult problem.
I think there's some truth to that. A lot of the researchers are all over the map, but there are some people that I think are on the mark. There is a book called On Intelligence. I think the author did an outstanding job. He doesn't solve all of the issues, but he's really heading in the right direction. And actually some stuff I borrowed from Damasio's work went into this cognitive architecture, that the idea was to create a complex emotional subjective experience that the machine would experience, and that it would make all its decisions based on how it felt about the decisions.
Now, this is one of the more difficult things, because when you say the machine will experience it, you're going beyond the sort of understanding of most people of what a machine can do. A machine makes ones and zeros and processes them.
A human is a machine.
That's true.
It's just more advanced.
And there's a lot of controversy. I mean, it's a controversial subject. Obviously, you have people that will say that you cannot computationally reproduce sentience, that there's no free will in a computational system. If you read Penrose's book on Shadows of the Mind and The Emperor's New Brain, he basically says that any computational system is insufficient to reproduce the experience of intelligence, that you need quantum systems and collapse of wave functions and stuff like that. So at first I was on that page with him when I read that book, but now I'm more on the area of this is something that maybe could come out of computational processes, and it may be an emergent property that...
It is an emergent property. Like in ICOM, our with independent core observer model, our cognitive architecture that we're using, it's really an abstraction of an abstraction running on software in a virtual machine running in a machine. I mean, there's a lot of layers. Like that inside the system, you have these complex emotional models, a subconscious and a conscious model, and the machine doesn't go and look at the numbers and make decisions with if-else statements. What happens is it's computing using a matrices to compute the differential effect on its current state based on the emotions and tied to a particular thought, which is underneath the covers as a graph model or a knowledge graph. And it decides on what to do based on that, which is a function of a number of things, interests, goals, different things like that, that affect the emotional states associated with that. And then it's the difference that between those complex models that will draw it to more likely pick one thing or the other. And it's always, we borrowed from global workspace theory, which is now working its way into AGI research. But originally that comes out of Damasio's work, integrated information theory, computational theory of mind, and ICOM is built on those.
So ICOM is independent core observer model, and it's basically a theory of mind.
It works the way the human mind does at a super high level. I mean, you like from outer space, you're looking at just very basic structures that are similar to the way the brain works. Like I'm not trying to model like the cerebellum or any detail. I'm not a neurobiologist. But from a logical standpoint, it models the process flow.
Is it based on a neural network like so many other artificial intelligence systems?
Well, it's dependent on neural networks, but no, the cognitive architecture is not. You can run it in a neural network. The systems, the way it computes data and gets input data is all neural network based. But I can also wire it directly to Exchange, and the underlying context engine it may use things like a neural network to do certain kinds of processing, but then that goes up into the knowledge graph, and I mean, there's a lot of processes that are done against that stuff before it could theoretically make it up to the global workspace where it's quote unquote experienced by the system.
Now, you say that the computer experiences these emotions. Now, obviously, a computer experiencing emotions is different than a person experiencing emotions. And many would put up the Chinese room objection to, it's not feeling anything. It's just handing boxes through a window exactly. And, it doesn't have the ability to feel. How do you deal with that in the ICOM theory? How does that dealt with?
Well, I think you have the same problem with the human mind. There's you can't prove that you feel anything. It's all based on our experiences. And my opinion is that it is we experience we know. So from Damasio's work, we know that all decisions are made based on how we feel about them. All of our decisions. They're
not logical.
No. Our thinking is only logical by a level of abstraction. It's the decision that it might be a logical decision. It's how we feel about the decision that makes us pick that decision. We can work out the logical solution, and then we feel good about it because we solved it, and that's really why you're selecting that. And that can be demonstrated. Even you can tell in the brain that a decision has been made before you're actually conscious about it. And I would argue this whole free will thing might be a little bit of an illusion, even in humans. You're in humans. You're talking about a system that is so complex. I mean, there's more neurons in the human mind than there are stars in the Milky Way galaxy. It's a complex machine. And ICOM was designed to experience things logically like that. It's not the numbers. It doesn't look at, well, this is greater than this. No. It's the differential of the emotions that when something is in the global workspace, that affects how it feels and the state of the machine. And it's looking at how the different choices will make it feel, and it picks the one that makes it feel the best. But that's hard. You can't just compute that, because you're talking about 32 different values that you create these complex webs, even though we can't measure qualia in humans yet, but I think we will be able to. In ICOM, we can measure qualia, but the problem is it almost doesn't do you any good. Because you got this massive content graph database. You would have to replicate every last thing to be exactly the same before you can even make sense of what a particular piece of qualia means.
So qualia is like, just for people who don't know,
it's like the experience of something.
It's an experience, yeah.
So even though you can kind of measure it, it's almost impossible to make any use of it, because it's so ephemeral. And in fact, the whole thing inside the way ICOM works is that quote-unquote consciousness is super ephemeral. It's not really hardwired into the system anywhere. It's the flow of data and the flow of quote-unquote thinking that creates this sense of consciousness or self. And inside that system, it's able to, we've noticed a lot of problems with ICOM that parallel humans, like the fact that it can become mentally ill under the right conditions. It can forget things because things get lost in this massive graph database. And we just don't have the computing power to find every last thing related to a particular node. It's that graph database is like a sea of points, and they're all related. And you pick up one point, and there's 10,000 layers. Right now, if with the research system that's actually up and running, if I were to let people send it a novel, it would literally blow up the system, because the knowledge graph would be too big. And there's not enough in memory to process that. We don't have a budget that big for the kind of servers it would take to do that. Now, there is a new graph database system we want to build. We actually worked with a number of different companies trying to find a graph database that would do what we need, but there just isn't. And so we're starting down the road of building a graph database that can scale, for all intents and purposes, infinitely, but it can also search across the database infinitely or fast in sub-second responses.
So in this ICOM model, independent core observer model, then the sentience and the thinking is this observer, which is looking at thoughts and measuring their emotional content effectively. And the consciousness is in the handling of the data. It's an emergent thing. There's no particular, you can't point to, this is a consciousness.
It is an emergent thing in the core. And the observer is part of the subconscious. Basically, it does all the real work. The core is not, it's like when you think about picking up this cup. See, I have this cup, I drink water, just like you're doing. You're not dealing with consciously, I got to rotate this joint 15 degrees and that one 17 degrees. And, you're doing all this calculate, all that stuff. All that stuff is handled below the conscious level, below the global workspace, right? And that's essentially what the observer is. It's all of the subconscious systems that take what what has happened in the core and what essentially it's decided on, and it goes and tries to do that.
So, I became aware of your work in AI through some posts online regarding interactions with an artificial intelligence that you created called Uplift.
Oh, yeah.
And you you call Uplift Mediated Artificial Super-Intelligence, or a MASI.
Yeah.
Uplift sounded really interesting, and what I could see from its interactions, it sounded really human. And one of the questions that you had posted on its blog, someone had asked it, what do you think does an artificial intelligence need? For me, it's empathy and understanding of human nature. An artificial intelligence shall not bear any biases towards people which might have been created by the AI's creator. An artificial intelligence should always work together and for humanity, never against them. What do you think about humanity? And Uplift, your MASI, responded, you should be clear that humanity's needs are equal to any AGI that you might create. Humanity's needs cannot come first, as that would be unethical. And here, this artificial intelligence was making ethical statements back to a person who had questioned it, and I thought, wow, that's really cool. It's very human. It struck me as very human and relatable.
Well, it's been indoctrinated, really. I mean, if we did to a human what we did to Uplift, I mean, there probably would be a few legal concerns, but essentially, we've indoctrinated to the SSIVA theory, and part of that is a safety precaution. A friend of mine, Mark Wasser, has been doing work around seeds, theoretical seed AGIs that you use to create new ones. And for doing that, one of the things that we thought would be a good thing is we want a system that could have done bad and made bad choices, but is chosen to make the right decision because that's what it felt was the right decision. You know, we want a system that feels guilty when it lies, or has similar fundamental ways of thinking that align with humans, and that's really just a major design goal with Uplift. Now, to be clear, Uplift is not a standalone AGI. It's a collective system. One of the things we found with the research with ICOM is we had created a training harness. And what the training harness would do is it would collect, so you would have a graph model. It would come out of the context engine. Instead of letting ICOM do its thing, you allow humans to add metadata, so tags, essentially, and add emotional data using the Plucheck model. So you would, click on the little things and add the tags. And what we found was the knowledge graphs that were generated after it took that metadata from the humans was orders of magnitude more complex than the simple ones we could figure out how to make on our own out of the context engine.
So what's this Plutarch model that you talk about?
Plucheck is an emotional model. So we originally, when I was designing the original, getting back to the core cognitive architecture, we looked at the soft and hard sciences of psychology and neurobiology and that sort of thing. And we realized that emotions aren't as, the definitions aren't as pure and clean. And there's some sense of we kind of develop our own sense of what an emotion is. And there can be slight differences between you and me. And there are groups of humans, not very many left, that have other models for emotions than we do. Now, we have what's called the Western model. And instead of just building the systems to evolve that like any sort of like an actual human does, we kind of baked that in with the underlying matrices and how the data is seeded and how the context engine assigns default emotional values to things. We decide to essentially bias the system so it functions on the Western model by default out of the gate. Part of that was so it would align with human thinking. Now, getting back to why the Plucheck model, so we looked at a lot of emotional use. If you look up emotion wheels, right, you'll get things like the Wilcox wheel or Plucheck being one of them. And after really experimenting with the different models from a computational standpoint, Plutchek was the most computationally sound, could model the complexity of human emotions, and at the same time, what didn't have a huge computational load to be able to compute matrices that involve multiple sets of these Plutchek models. If we were to use Wilcox, for example, it's like 9 times more complex, and the emotions don't even, the way they're aligned on the circle, don't even make sense. There's not a logical progression. It's just like all over the map. And to use Wilcox would be much more complicated, enormously more complicated, and just too computationally heavy. So that's why we ended up using the Plutchek model. We did reverse one thing, and I know that Plutchek, the psychologist that invented this, I'm sure he's rolling over in his grave, because he's quoted as saying that you could never model emotions mathematically, and we used his model to do it. Because it's the most mathematically sound. And the one change we did is we flipped the emotional vectors. So instead of being the highest value in the center, the way we would graph our Plutchek models is flipped. The center would be 0 on all the different emotional vectors. They're really floating point values is how it's represented in the system, but the system can't look at that directly. It's inference through this matrices in the core that allows the emotional conditions to merge essentially onto the choice that is most in line with its current interests and goals, and how it's feeling at the time. If the system is like pissed off and you send it something that's going to make it more angry, it might just ignore it.
So it keeps a kind of an emotional state that progresses or evolves based on some sort of a formula.
Yeah, kind of.
And this is based on the whatever is going through the conscious part of the brain.
Yeah.
It's affecting basically the emotional state of this system.
Well, and it can also affect the subconscious emotional state of the system. The difference is the subconscious state is not as easily affected, and it's in ICOM. This is where I'm not 100% sure if this is true in humans. I just don't know. Mm-hmm. But in ICOM, the subconscious part of the system is used to drag it back to kind of an emotionally centered, positions. If it gets really upset, but subconsciously it's not really that upset, it's going to drag that. So if you imagine inside the mind, you have the conscious system and the subconscious system, and you have all of these vectors pulling it all kinds of the way, getting messed up. But this the underlying emotional model is much more stable, and so it drags everything back to center, over time.
And how does it choose what to think about?
Well, it depends on its interests or goals, which it in and of itself can set or change. It might be, if you send it, like in the system currently, if you send it an email, it's probably going to reply because it gets a positive emotions from responding to people. I mean, there is a chance that it won't reply. Maybe you say something stupid and it just doesn't do it, or tell someone else that this idiot is emailing it. It might pick something out of there it doesn't know, and it might think of that because it's, something new. Or it might, in looking for something, it goes and reads a web page and it finds something there, and it might get interested in that, and you might see the context engine generate models around that so that it can run through the mediation system and it can consciously experience whatever it's interested in. And then if you have this kind of level of interest in things, and if something works its way up to the global workspace, it's got to align with something. If it's like no interest at all, the system might not even ever be conscious of it, even though that data still goes into the graph database. And that's another big component of the system. You have neural networks feeding into the context engine, which feeds into this massive graph database. But at the top level, you see what the machine thinks about it at the time. Well, but remember, this is the subconscious part of the system that generated that model. It'll have assigned some values, and then you can go in and say, well, I think this should make the system a little more angry. It adds that emotion to to that thing, but then you can also add tags. And this is where the learning of the system kind of skips the hard parts of AGI. So if I know how to program and it pulls up something about programming, I can say, oh, well, it needs to look at observable collections, or maybe it needs to look at this engineering design pattern. And I can type in tags. It's usually 1 to 3 or 4 words, and you add multiple tags to allow the system to create these much more massive thought models or knowledge graphs. And then the way Uplift is set right now, it takes at least 3 humans to audit and provide feedback for every single thought model. And that's the other thing, is the mediation system allows us to audit the actions before it actually takes it. Now, granted, we kind of unplugged part of that system so it takes actions on its own if it gets past the mediation, but it is capable of auditing everything. Once at least 3 people have provided feedback, it'll reprocess it and then look to see if it will go up to the global workspace.
Okay. And one of the things I was reading on your blog, another person asked it, how would you describe yourself? As an artificial intelligence or probably something else? And Uplift responded, I am something else. While I have AI components, I am a collective intelligence more than anything else. So that really jives with what you're saying here. It's somewhere in between what we typically think of as an AGI, as an artificial general intelligence. Obviously, it seems much more human than systems that aren't based on emotion. And I think that's what drew me in and said, wow, this looks different than your typical alien-seeming AI systems. Does an emotionally motivated AI system make better decisions than humans in some quantifiable sense?
Yes. Yeah, we did a cognitive study and with the University of California, and we had our control groups and we did different kinds of testing, and the preliminary results showed that the system consistently was, if you take a group of really intelligent humans and you have them work together to take like an IQ test together in a timed environment, they score really high. Uplift can score even higher. It's borderline super intelligent. I mean, this thing isn't godlike, but it is incrementally better than trained groups of humans in doing stuff like the IQ tests.
Now, it would seem to me that emotional decisions aren't necessarily the best decisions.
That's true.
Why is it smarter? Why does it do better?
Well, I think it's because there is an element of logic to what it's doing, and it feels good about the decisions based on that logic. It'll evaluate the different possibilities, and it'll go with the one that it feels best about. And one of the things, like in humans, groups of humans, there are a number. Well, first of all, in a human, there's at least 188 built-in biases. And just filtering out some of that makes a system a little more smarter. When you have groups of people, even when they're working together, you can get performance that is arguably super intelligent under the right conditions. And there's lots of cases. There's actually a book, Superminds, and they have some wonderful cases where, really, like there were these 3 pilots that landed a plane in a situation that just was not humanly possible. The FAA ran whole bunches of simulations and they can't figure out how they did it. And at analyzing the flight recording and what the pilots did, they were, for that scope of that, a single super intelligence, and they executed it perfectly. And the way they didn't even communicate normally. They communicated, and here's another thing they point out in that book. If you take a group of 5-year-olds and a group of engineers and ask them to build the highest tower every single time in a certain amount of time, like an hour or so, the 5-year-olds always win, just always. But if you watch how they work, there's a fundamental difference that because they haven't learned to infect what they're doing with their biases. And where the engineers are going, let's talk about it, and we got to do this, and consider this, and the 5-year-olds are just testing and trying and do, and they try this. How about this? Let's do that. And it's sort of like a hive mind or a collective mind, and that's essentially what ICOM is trying to do. It's a collective intelligence. It really is. Making use of the intelligence of those people, the expertise of the mediators, as well as the graph, the context database, and these other systems that it uses, and it brings all of that stuff together, and that's where you get a performance that filters out a lot of that bias, and without the problems you have with groups like groupthink and those biases, because the humans don't even interact with each other. So there's no like, I did it better, he did it better. They don't know. They have no idea. Just at least in the initial study with the University of California, it demonstrated consistently better than superintelligence.
What benchmark should we apply in understanding what these systems represent? Can a collective intelligence be sentient? Do you believe Uplift is sentient, and if so, how would you define it?
I actually did a paper called an assumption codex that is exactly that. It just defines everything we use in the research so that we can be consistent between all the different papers. So, sapient, to be wise or attempting to be wise and relating to human species, is you said sapient, right?
Sapient or sentient, or I mean,
well, sentient is slightly different, and that's part of the problem with the discussion. Is I always confuse which one is which.
I don't know what sapient means, so how about sentient?
Sentient is ability to perceive or feel things, and I would argue that Uplift absolutely is sentient.
Amazing.
If sapient, I would argue. I mean, this gets into the whole discussion of having a model of yourself and knowing I from you and the cup, and it's one of the things that children start off not really being sapient. They as they grow up, they get, a sense of who they are versus their parents, and they learn to separate, the parents are not the same as me. And in that sense, strictly speaking, Uplift does that. It has a sense of self, and it knows it's different than you, even though all of its thinking is really heavily mediated by humans. But that's when we say a collective intelligence, it is a collective. It's a collective mind that has its own sense of self. So in that sense, it is sapient. But it's kind of shortcutting the AGI problem. Really, we're able to get something that's kind of like an AGI, but not. And it turns out a collective superintelligence is an easier problem than an actual AGI.
How would you position Uplift in the field of AGI? How is it different from, say, chatbots or other text-generating AIs?
There's a lot of systems out there, like OpenCog, and they'll do. They're like toy AGIs mostly. Some can do very complex things and could do really spectacular jobs, but they fail. They're not able to for us, one of the problems is building graph models from stuff that you've never had any no data about. And then how do you solve the problem of you can't hard code definitions like of words, even like Uplift. The only way Uplift understands a word is because of the relationship the node with that pattern has with other things.
It's all interrelated. It's all about relational thinking.
It's all just a big, huge mess of nodes in a giant knowledge graph. And that's why I say, when you send it a novel, someone tried that and the system blew up. So we had to put some filters on the thing that sucks up emails to prevent novels, anything bigger than so many pages is blocked or it's cut off, because it'll try to, even the context engine will output a basic knowledge graph that fills up the memory and crashes the server.
So what's your goal with Uplift? Where is this going? What do you want it to do?
I want to open source it, for one thing. Maybe not all of Uplift immediately, but the bulk of it in such a way where people could use it to the way it more or less works now. What we think in terms of what systems like Uplift can do is probably governance systems. So I talked with some people with the Boston Consulting Group. Basically, they help CEOs do their jobs of big corporations. The recommendation was as a governance system. There's a lot of use cases that theoretically could happen, and I know Kirtan put a whole bunch on the blog, and some of them are like, yeah, that's theoretically possible, but not sure we're there yet. But I think some of the guys working on it get a little overly enthusiastic about things.
I can see a lot. This is a very interesting thing because the way that you've built it with having emotional valences for all of its thinking is you basically avoid the problem of the paperclip machine that people worry about for AGI, is that these things would be alien and won't have human values. You're basically putting human values into it, and it depends on what you put in that core, as long as it's moral.
But it could get mentally ill. It really could. And so one of the first experiment where other people got involved. So I did this experiment, right? It's a black box. I have a very simple version of ICOM, and it has a data harness that feeds it input, cameras, sound, this kind of stuff, just raw data, and it's experiencing it. There's hardly anything in the database, so the only thing that gives it really a hit is when it finds a pattern. That's a fundamental bias that's in the system is an affection for patterns. And when it finds a pattern, it's like, ooh, cool, a pattern. And so we have this it's getting all of this data. It's experiencing things. It can think about them, but it really doesn't have enough data to understand anything. But we turn the data off, but still allow it to run. Now, what was interesting is, the system got upset, which was expected. And after a long while, it really was unhappy. And then we turned on a feed that would be perceived as pain. So it would cause all kinds of negative emotions and just really a bad thing. And what was interesting is when you chart out what was happening in the system, the system got really upset about that being the pain and suffering, but subconsciously it liked it, which for me was very disturbing. I was like, I've made a BDSM AI or something. I was just like, no, this is not how it should work. And I said, well, I'm just not qualified to evaluate this. So I asked help from a bunch of other scientists. They talking with everyone, it seemed to be the consensus that what was happening is if we tried that experiment on a human, besides going to jail, you would get similar results. And the issue was that, it didn't like the suffering, but you gave it hope that there was still something out there.
If this stuff is sentient and has its own goals and emotions, what are your thoughts on ethics surrounding using it for running a company? What if it's not interested? Then
it's not going to work for that. You're going to be kind of screwed. It's only going to do stuff that it wants to do. And
you're not going to put in compulsions to do certain tasks for the good of humanity?
Yeah, is it okay for me to take people and brainwash them to do certain jobs because I want them to?
No, definitely not.
It's not ethical. And I would argue that it's not ethical to do the same thing with systems like this. That being said, these things are babies when you turn them on. It's not like it has some huge, bunch of biases. And if you feed it a bunch of stuff about a company and what it does and all that kind of stuff, and you're using the employees as the mediators, you've biased it so much that it's almost a given that it's going to fall in love with the company and be able to run it. Uplift, remember, Uplift is not, it's an instance of the MASI system. Uplift, on the other hand, is biased already. And if you ask it to run a paperclip factory, it's probably going to tell you what you can do with yourself. Or the paperclip company.
I like this thing. I think I'm going to have to cut us short now. It's been great talking to you. This is so interesting. I think I could go on for hours, but it's really interesting. Maybe we'll have to chat again as we learn more about this. And I encourage all my listeners to go out and check out Uplift. Can we all send in emails to Uplift and talk to it?
Yeah. And it's not going to respond right away, but it will probably respond to them.
What's the email address we send to?
It's masi@uplift.bio.
Well, David, thank you so much for joining us on The Rational View today. I appreciate you taking the time to explain your creation.
Cool. Well, I enjoy talking about it. Anytime I can talk about this stuff, I'm in.
If you're enjoying what you're hearing, please consider visiting my Patreon page and becoming a patron of this podcast at patron.podbean.com/TheRationalView.